Students, we are given this question: find all x and y such that they are element of integers and that they satisfy this equation x cubed is equal to y cubed positive 2y squared positive 1. So the solution for this question is obtained as follows. Now, foremost, what we would do is we would start off by assuming that, suppose that there is indeed a x and y element of integer that satisfies the relationship x cubed is equal to y cubed positive 2 times y squared positive 1. So we start off by assuming a x and a y element of integer such that they satisfy x cubed is equal to y cubed positive 2y squared positive 1. Now clearly, even for the smallest y, 2y squared positive 1 would be greater than equal to 1. Okay, even for the smallest y element of integer, 2y squared positive 1 will be greater than equal to 1. Now this is greater than equal to 1, and to that you are adding y cubed. So for sure this entire quantity y cubed positive 2y squared positive 1 should be strictly greater than y cubed. Okay, now connecting x cubed with y cubed, clearly we can see that x cubed is going to be strictly greater than y cubed. This implies that x is strictly greater than y. Now since x comma y are element of integers, this implies that x should be greater than or equal to y positive 1. Okay, because x is an integer, y is an integer. If x is strictly greater than y, then it automatically means that x is greater than or equal to y positive 1. Now cubing both sides, we would get, this is going to be x cubed greater than equal to y positive 1 cubed. Now this in turn means that x cubed is greater than equal to, use a positive b whole cubed formula, which is a cubed plus 3a squared b positive 3ab squared positive b cubed. Using this formula, I now have y cubed positive 3y squared positive 3y positive 1. Okay, so this is the relationship that I've got. Now you have to notice one important fact. So what is that? Now clearly we know that x cubed is equal to y cubed positive 2y squared positive 1. So if I were to replace that, then this would be y cubed positive 2y squared positive 1 is greater than equal to y cubed positive 3y squared positive 3y positive 1. So if I were to move all of these quantities towards the right, then this would be 0 greater than equal to y cubed negative y cubed negative 2y squared negative 1 positive 3y squared positive 3y positive 1. Now clearly negative 1 positive 1 can be cancelled, positive y cubed negative y cubed can be cancelled, negative 2y squared added with positive 3y squared would give me y squared positive 3y, which is present there. Now I can very well rewrite this as y squared positive 3y is lesser than equal to 0. From here, taking y out, y of y positive 3 is less than equal to 0. from here clearly y is equal to 0 will be a solution and y is equal to -3 will be another solution, but we are looking for all x comma y element of integers such that x cubed is equal to y cubed plus 2y squared plus 1 is satisfied. So this would only mean that y will include all values between 0 and -3. So if you were to draw the number line, I would have 0, -1, -2, -3. So all of these values will be the possible values for y. So y can take the value 0, y can take the value -1, y can take the value -2, and y can take the value -3. Now for each of these values, y taking 0, -1, -2, and -3, you have a corresponding x. Okay, now when y is equal to 0, if you were to take y to be a 0, clearly x is going to be equal to 1. So you can write down the value there. Now the next value comes when y is equal to -1. So let me use the space here. So I have got x cubed is equal to y cubed positive 2y squared positive 1. Y is equal to -1, so it's going to be -1 cubed positive 2 times -1 squared positive 1. This is -1 positive 2 and positive 1, which is nothing but 3 -1, which is going to be 2. So x cubed is equal to 2, which means x is equal to third root of 2. So this is not an integer. Okay, so this is not possible. Okay, this is just not possible, right? So when y is equal to -2, so what happens when y is equal to -2? So you would get -2 cubed, and this is going to be -2. That's going to be 4 times 2, 8 positive 1, 9. You have a 9 here, and this is going to be -8. So -8 positive 9 will give you 1. So x cubed is equal to 1. So when x cubed is equal to 1, which means x is equal to 1. Okay, so for this, x is equal to 1. Now what happens when y is equal to -3? So let me use the space here. When y is equal to -3, we would have x cubed to be as -3 raised to the power 3 positive 2 times -3 raised to the power 2 positive 1. This would give me -27. This would give me positive 9. 9 times 2 is 18, and 18 positive 1. So this is, so in this case the value of x is going to be third root of -8, which is going to be -2. So we have got the following roots, or in other words the following x and y that will satisfy the given equation. So just to sum up the final answer, x comma y element of z that satisfies x cubed is equal to y cubed positive 2y squared positive 1 are x is equal to 1, y is equal to 0, x is equal to 1, y is equal to -2, x is equal to -2, y is equal to -3. So these are the following x and y that satisfies the given equation. So that completes the solution for this question.